All right, welcome to our second day of our Trig review. We're going to do a little bit of vocabulary today. We're going to do a lot of drawing angles, and we are going to talk about converting to radians and measuring angles in radians. I know this was something that some of you guys were struggling with when we first introduced it, so please tune in for this and make sure to practice. All right, so let's talk about drawing angles. All right, so you guys can see we have a coordinate plane here. We have quadrant 1, 2, 3, and 4. Okay. When the terminal side is rotated counterclockwise. So as we go around, we're always going to go counterclockwise. As we do that and go counterclockwise, the angle is positive. So all of our positive angles measure in the counterclockwise direction. So we start at that positive x-axis, we measure counterclockwise. When the terminal side is rotated clockwise, this is going to be when we have a negative angle. So if we go this way, that's when we're going to have a negative. Okay, so positive and negative, remember, determine which way we travel around our coordinate plane. All right, so we're going to draw a few angles. And remember, we're just estimating where these angles go. So as we think about a coordinate plane, if it helps you, if we're in degrees, we know we're 90 up there, 180, 270, and 360 is going to go all the way around, right? So as we do this, we're going to go 145 past 90, not quite to 180, and it's going to be somewhere like here. And there we go, and that's positive, so that's in our second quadrant. It's always helpful to label those quadrants. 215, we know this is 180, so we're going to go past 180, and we're going to go past that by 35 degrees, and there is our 215 degree angle. Negative 105 means we're going to go this way. We got to pass 90, and we're going to go just a little bit past there, and there's negative 105 degrees. All right, so that's a pretty quick review. But it's that easy. When we remember where they go, we can just sketch them like that. All right, so now let's talk about radians. Got a lot of stuff typed in here. Write this stuff down, print these out, have them ready to go when you guys are doing your quiz next week, and you'll be good to go. Radians are the alternative measure degrees. So these are two different ways we measure angles. A full revolution is measured in 2 pi, half is pi. So as we think about this, as we move around our coordinate plane, right? We go half a revolution is pi. All the way around is 2 pi. So that means this is 1/2 pi, or pi over 2. And this is 1 1/2, or 3 pi over 2. All right? And if we think about that, that's how we break up that quadrant, or that coordinate plane, into different pieces as we use radians. All right? So let's see, let's fill in these blanks. When the terminal side is rotated counterclockwise, same thing, right? Counterclockwise, the angle is positive. Clockwise, the angle is negative. Same thing as with degrees. All right, so let's draw some angles in radians now. And remember, we're going to use these denominators to help us. So if our denominator here is 6, remember, this is pi. So pi is 6 pi over 6. 1 pi, 6 over 6 is 1. So that means that this is going to be half of that, which is 3 pi over 6. So label these to help you. 3 pi over 6, 6 pi over 6. Another half would be 9 pi over 6. And all the way around would be 12 pi over 6. So use that denominator to help you figure out where this angle is going to go. So 5 pi over 6 is less than 6 pi over 6. And it's going to be right there. And there's our angle, is 5 pi over 6. 5 pi over 4, let's do this again. Okay? So use our same denominator. 1 pi is 4 pi over 4. Half of that is 2 pi over 4. Okay, 2 pi plus 4 pi. So 4 plus another half is 6 pi over 4. And all the way around is 8 pi over 4. So 4 times 2 is 8. Label those. That's going to help you guys a lot. 5 pi over 4, 5 is halfway in between 4 and 6. So that puts it right there in our third quadrant. All right. All right, now we have thirds. Let's do the exact same thing. All right, we're going negative now. So 3 pi over 3 would be here. If I go positive, I'm going this way. If I go negative, I'm going this way. Okay, so negative 2/3 is going to be right about there. Negative 2/3 pi, because we're going to go now clockwise because it's negative. All right. Again, I know this is a quick review, but pause it, watch it again, practice a couple on your own. All right. I'm going to keep cruising. All right, let's do some conversions. Some of you guys figured out some good ways to do this. I know it's been a little while, so I got a little chart up here for you guys. Remember, these are conversion factors. Okay, 180 equals pi. That's what you need to remember. Now, remember, whatever we want goes on the top. So I want radians. It goes on the top. I want degrees. It goes on the top. All right, so check this out. I start with degrees. I want radians. Radians goes on the top. Degrees goes on the bottom. It's always pi and 180. So all we do is we multiply those things. And really, all you have to do mathematically is take that 120, divide it by 180, and stick a pi next to it. So simplify that, and let's see what we get. So that's just 2/3 pi, or 2 pi over 3. All right? Starting with degrees again, I want to change to radians. I'll put it over 1. I want radians, so pi goes on top, 180 goes on bottom, and I'm just going to simplify this. Negative 60 over 180 times pi. And negative 60 over 180, if we simplify that, is negative 1/3 pi, or negative pi over 3. You can write it either way. All right, 3 pi over 4. Now I'm starting with radians. I want degrees, so that means 180 goes on top, pi goes on the bottom. And this is why this is important, because see how the pi's cancel here? That's what we want to happen. And all you guys need to do, again, multiply your numerators and divide by 4. So when I do this, I put in my calculator 3 times 180, hit enter, and divide by 4. And I get 135. And that's it. So that's all you have to remember with those guys. Pi equals 180. And you just use your conversion factor with what you want on top. All right, so now next we're going to talk about coterminal angles. Some of you guys are getting coterminal angles mixed up with reference angles. Coterminal, remember co means same. Co means same. So it means we have the same angle, we just have a different measurement. So they're in the same place. So check this out. If we look at this first one, this is negative 300 is all the way around here, okay? But I could also draw this angle by simply going from here to here. All right, that's a coterminal angle, 60 degrees, right there. Okay, I could also do this angle by going all the way around and adding that 60 degrees again. Okay, that would give me 420. So you can see all three of these angles are in the same place, but they have different measures. Negative 300, 60, 420. And all we have to do to find a coterminal angle, okay, is that we add or subtract 360 degrees. Because all that does is spins us around that coordinate plane. Spins us around that coordinate plane. If we subtract, spins us around the coordinate plane the other way. In radians, to spin around the coordinate plane, we're going to add or subtract. Again, 2 pi. 360 is the same as 2 pi, so one revolution around is 2 pi. All right, I'm not going to do all these. I'm going to do a couple. I'll do a couple for you guys. All right, positive and negative angle, reference angle. So add 360. There's one. Subtract 360. 130. minus 360, negative 230. There we go. Two coterminal angles. It's that easy, guys. All right. Let's go to, let's see, number 4. This one's interesting because a lot of you guys like to just say, okay, add 360. And there we get 1. Subtract 360. And here we get another coterminal angle. Now, here's the problem. If I ask you guys to give me one positive and one negative coterminal angle, if you subtract 360 here, you get 70. Is 70 degrees a negative angle? You should be saying, no, Mr. Chomecki, that's a positive angle. So how do we get a negative angle? We simply subtract 360 again. So 70 minus 360 is all we're doing is we're spinning around that coordinate plane one more time. And there we go. There's one negative. There's one positive. And I don't care if you gave me 790 or 70 for your positive one, but make sure you give me one negative one. Okay? All right, let's do this one time with radians. Actually, we'll do it twice with radians. 3 pi over 4, because here's where our common denominator practice can come into play. I got to add 2 pi. And when I add 2 pi, since I'm adding it to a fraction, I need a common denominator. So my denominator is 4. I got to multiply times 4 times 4. So I got to do 3 pi over 4 with my common denominator then. 2 pi over 4 is really 8 pi. Sorry, 2 pi is really 8 pi over 4. And now I can add my numerators and keep my denominator the same. There's my positive. Now when I do my negative, I already have my common denominator. So just do this again. 3 pi over 4 minus 8 pi over 4. 3 minus 8 gives me negative 5 pi over 4. And there's our negative. All right, let's do it again. Negative 2 pi over 3 plus 2 pi. Get my common denominator. I need to get my denominator to be 3, so I multiply times 3. Negative 2 pi over 3 plus 6 pi. Notice all we're doing really is we're multiplying whatever that denominator is by 2. And that is what we add or subtract. So negative 2 plus 6 gives me 4 pi over 3. There's my positive. Negative 2 pi over 3 minus 6 pi over 3. Negative 2 minus 6 gives me negative 8. So it's negative 8 pi over 3. There we go. All right, you guys can work out those other ones. But again, that's all there is to it with coterminal angles. Remember, co means the same. So the same angle with a different measurement. Okay, so they're in the same place. When you draw it, it's in the same place, same angle, they just have a different measurement. All right. All right, so now let's talk about reference angles. We got some rules here. All right, check out these rules. So first, reference angles. Positive and acute. Formed by terminal side and x-axis. Has to be with the x-axis, okay? Please remember that, positive and acute, x-axis, all right? So as you look at this, we got some nice pictures over here, all right? As you think about it, if we're in quadrant 1, the reference angle is here, it's the same angle. If we're in quadrant 2, the reference angle is here, which means we're going to take 180 and we're going to subtract the angle. If we're in quadrant 3, the reference angle is here. So it means we're going to take the angle now and subtract 180. If we're in quadrant 4, we're going to be right here. So we're always going to that reference or to that x-axis, and we're going to take 360 and we're going to subtract the angle. Okay? All right. So again, remember, positive and acute. Okay? Reference angle is always positive. Doesn't matter which quadrant it's in, it's always positive. Doesn't matter if you have a negative angle measure to start with, reference angle is always positive. And we always draw it either up or down to the x-axis. Never over to the y-axis, always up or down. Okay? So let's do a couple here. So here's 130. 130 is going to go past 90, be right there. That's 130 degrees. So what we want to think about is the difference to get down to my x-axis right here is going to be 180 minus the angle. So to get down to my x-axis is 50 degrees. That's our reference angle. That's all you have to do. Just make sure, remember, always think about it to the x-axis. So 200 goes past 180, and it goes past 180 by 20 degrees. So that's 180 plus 20, or think about it, 200 minus 180 equals 20. There's our reference angle. Okay, 15, that's easy. That's just 15 because it's in quadrant 1. Okay. 430 is going to go all the way around, and that's 360. So let's do this first. We go all the way around once. 430 minus 360 gives me 70. And that's going to put me back into the first quadrant. So that means my reference angle is just 70 degrees. Okay? All right, now as you guys do radians, I know that you find this a little bit trickier. Okay? Label your axes with your radians. So remember, 3 pi over 4. 4 pi over 4 is right here. Okay? So this is 2 pi over 4. And this is going to be 6 pi over 4. So if you guys think about where that angle is, 3 pi over 4 is going to be right in the middle between 2 pi over 4 and 4 pi over 4. So to get here, there's 3 pi over 4. To get down to my x-axis, I need one more pi over 4. Or again, if you like to do this idea, 4 pi over 4 minus 3 pi over 4 equals 1 pi over 4. Okay? And the last one, negative 2 pi over 3. So we're going this way now. Let's see. Negative 3 pi over 3 would be all the way to here. So I only want to go 2 pi over 3. So I'm going to be here. And in between that angle and my x-axis go up, it's going to be pi over 3. All right. So hopefully that was a nice review for you guys. If you had questions on those before, try out some more. Email me. Let me know what else you need help with. That's it for today. Notice this homework builds. So after the first lesson, you were able to do the first couple problems. Today, you'll be able to do a few more. Again, email me if you have any questions. Hopefully, this is a helpful review for you guys. Again, these are really important skills for you to have in your classes next year. So make sure you're taking the time. And thank you to those of you guys that are. I really appreciate your work. I know this is not easy. It's not easy for me either. And I'm doing the best I can. So if there's anything more I can do to help you out, email me, let me know. I'm here for you guys. Whatever you need, let me know, please. My goal is to get all of you guys passing this semester and even getting your grades up higher than they were back in March, which some of you guys have already seen. So bravo, keep it up. I miss you guys. And if I don't see you soon on a Google Meet, hopefully I'll see you next year and you'll come and say hi. All right, I'm out.